So we're going to do a quick lesson on increasing and decreasing versus maximum and minimum points. So derivatives useful to find the slope, right? Up a hill it's increasing. This is where f prime of x is greater than 0. Down a hill decreasing, and this is where f prime of x is less than 0. Okay. So you find this gradient or the slope of a line, and you can tell if a function is increasing or decreasing. Reminder that derivative is the same thing as slope, which is gradient, which is the same thing as f prime of x. And we always walk from left to right. Okay, and that tells you everything that you need to know. This is an example of increasing, right? So every point along here, it doesn't have to be a straight line, but every point along here are f prime of x is greater than 0. It's a positive gradient or a positive slope. And every point around here, again, right, it's decreasing. So f prime of x is less than 0. Okay, pretty straightforward. Never drink and derive. Okay, remember that. Find the levels or the intervals where the function is increasing and decreasing for our function. Let me just go ahead and write down what that function is. So we have f of x is equal to 2x to the third power. Please write this down. Plus 3x squared minus 12x minus 5. Okay. So find the intervals where the function is increasing. So this is where f prime of x, again, is greater than 0. We're going to write this a lot. And again, from left to right, I can tell right here, right? All of this up until right here is where it's increasing. So this is where x is less than -2. And again, over here at 1 and on, x is greater than 1. Notice that you don't include these points because this is where our slope is 0. Okay. Perfect. So for the next one, for decreasing, this is where f prime of x is less than 0. So we can see from -2 to 1, -2 to 1, and x is in between those two numbers. Okay. If I want to do this a little bit more algebraically, I can find out the point, this point, and this point right here by taking this and finding the derivative of it. So f prime of x is equal to 3 times 2 is 6. 3 minus 1 is 2, plus 3 times 2 is 6, x, and 2 minus 1 is 1. You don't need to write that down. Minus 12, and the -5 goes away. And this is where we're going to set this equal to 0. So I can see that 6, and -12 all have a common factor of 6. So I can divide everything by 6. And I get f prime of x is equal to x squared plus 6 divided by 6 is x, minus 12 divided by 6 is 2, and we want to set that equal to 0. So here is where we can double bubble this, set it equal to 0, so I get x and x, two numbers that add to give me 1 and multiply to give me -2 are going to be +2 and -1. And last step, I'm going to take this over here, take the two numbers, x plus 2 equals 0 and x minus 1 equals 0. So I subtract 2 from both sides, and I get x is equal to -2 is one answer, and if I add 1 to both sides, I get x is equal to 1. And look, magically, this is where our max and our min are. Okay. So we can use the derivative to tell us if the maximum or min of a function, whether it's local or global. Want to refresh your memory about what that means. So if I have, I'm going to go ahead and just do this right here. Go doot doot. Okay. So I can tell over here this point is a local max, right? This is a local max point because in this range, this is a maximum. This point right here is a local min. Right, there could be, if I went something like this, if I went to my graph and did something like that, this here could be more of a global max. Global means for the whole graph, okay? There's no point that is higher than that. So this is a global max. And stationary points are just basically like max and min. So if I have a graph that looks something like this, if I go like that, we can tell stationary points are right here and right here. So this point right here is going to be a relative minimum point. This point right here is going to be a relative maximum point. And how do I know that? Because if I were to take this and draw a line that is tangent to it, the slope of that line is equal to 0, and the slope of this line that's tangent like that is also equal to 0. So our stationary point's a max or min. In this case, yes. It doesn't have to always be. I'll give you an example of where it is not a max or min. So if I have something that looks like that, right? The tangent line right here is equal to 0, right? That point right there is equal to 0. And in this case, this is not a max or a min, right? It keeps on going right here. It's increasing. So sometimes a stationary point are a max and min. How do you tell? It's where the derivative, the f prime of x, is equal to 0, and there's a shift or a change in signs. So here's an example of what I mean by that. All right, so just to refresh your memory, the maximum or minimum happens when the derivative is equal to 0. So I'm going to go ahead and find the derivative of this function right here. So 2 times negative 2 is equal to negative 4. X 2 minus 1 is equal to 1. I don't need to write that there. Plus, there's an imaginary 1 here. 1 times 8 is equal to 8. 1 minus 1 is 0, so that I don't need to write that down. And this goes away. So I'm going to set this equal to 0 here. Minus 8 minus 8. So negative 4x is equal to negative 8. Divide both sides by negative 4, and I get x is equal to positive 2. To find out what my y value is, I just go to my graph, I go to my table, or I could take the 2 and plug it back into the original. Across from 2 is the number 14. Okay, so y is equal to 14. So that is my point, 2 comma 14. Okay, so now what I'm going to do is I'm going to take this and see if there's a sign change. So this is where x is equal to 2. And let me pick a number to the left, a number to the right. So if I plug 1 into the derivative, 1 times negative 4 is negative 4, plus 8 is positive 4. So this is a positive number or a positive slope. If I take 3 and plug it in, 3 times negative 4 is equal to negative 12, plus 8 is equal to negative 4. So that is a negative slope. And you can tell here that the graph is going to go something like doot, which means that at x is 2 is going to be a maximum. So this point right here is equal to a maximum. And I just did that by hand. Okay, so for this next one right here, it's telling us a key thing. F of x has a local minimum when x equals 0, x equals 1, and we have to find out what k is. So just like we did before, the derivative of the function is equal to 0, so we have to find out that we know that now that f prime of 1 is equal to 0. So let's find the derivative of this point right here, or this graph, this equation. So 3 times an imaginary 1 is equal to 3. X over 3. 3 minus 1 is equal to 2. Plus, at this point, you should be good with finding the derivative. 2 times 3 is equal to 6. Divided by 2. X 2 minus 1 is equal to 1. I don't need to write that down. This one here is just going to be k, and this goes away. So I'm going to go ahead and simplify this function a little bit more. 3 divided by 3 is 1, so I have x squared plus 6 divided by 2 is 3x plus k. And all I have to do now is take wherever I see an x, I'm plugging in the number 1. So I have 1 squared plus 3 times 1 plus k is equal to 0. 1 squared is equal to 1. 3 times 1 is equal to 3 plus k is equal to 0. 1 plus 3 is equal to 4 plus k equals 0. Subtract 4 from both sides, and I get k is equal to -4. There's my answer. Just found out k. Okay. So let's go ahead and do some IB questions. So label the local minimum as A. So boom, A. Label the local maximum as B. Boom. Write down the interval where f prime of x is greater than 0, aka where the slope is increasing. So if I were to look right here, so this is at 0, this number right here, I'm going to go ahead and pause the video so I can show you. So I went ahead, plugged it into the calculator, and I'm looking to see where my function is increasing, right? So here's my minimum point. That looks like it is at the intercept, x-intercept, which is 0, 1. So it is increasing starting from 0 less than x, and I want to find out what this maximum point is right here. So to do that, I go to my calculator, I hit second trace, maximum is option number 4, and now I just need to do a little bit of moving, right? So I'm going to go somewhere to the left of the function. I'm going to go anywhere to the right of the function. I want to find out what this maximum point is. So I'll hit that, and I'm going to go to guess. It's somewhere around here. And I can tell that my maximum is going to be at 2. So from 0 to 2 is where my function is increasing. Draw the tangent to the curve at x equals -1. So I'm going to go here. So across from -1, I can see 5. So I'll go to my drawing. 5 is somewhere around there. So I'm going to draw a line that is tangent to that. This is going to be hard on the computer, but I will do my best. It's going to be a very steep slope, right? So something like that. This line should go a little bit more like that. You get the point, but this is the tangent line. All right, and write down the equation of the tangent at x equals -1. So I just went ahead and put in my function, so d dx. I put the original in, and I'm looking to see the tangent at x equals -1, and I get that the slope is equal to -9. So I have here the slope is equal to -9. The formula for a line is y equals mx plus b. So I just found out that my slope is -9, so I have y is equal to -9x plus b. I already have a coordinate, which is -1, 5. So I'm going to go ahead and plug this is my x, this is my y, so I have 5 is equal to -9 times -1 plus b. -9 times -1 is 9, plus b is equal to 5. Subtract 9 from both sides, and I get -4 is equal to b. So my full answer is going to be y equals, my slope is -9, so -9x, and then my b is -4, so -4. So this is the equation of the line that is tangent at x equals -1. All right, so next one, I'm going to plug this into the calculator. So I notice when I plug it into my calculator, I'm not seeing the whole graph, like I'm not seeing what happens over here because it says t or x is greater than or equal to 0. So I'm going to do zoom and go to something called zoom fit, which is option number 0. So let's go ahead and see what my calculator gives me. So it gives me something that looks like this. Do I see my maximum? I do. Okay, this is decent. I wouldn't need this much negatives, but oh well. All right, so for the first one, it's telling us, says, write down the height of the tower. So if I look at my calculator, I look for the height of the tower, which is my y-intercept. So across from 0 is the number 8. So the height of the tower is 8, and this is in meters, so this is 8 meters. Calculate the height of the cannonball 5 seconds after. So across from 5 is 58. So this is going to be at 58 meters. So right now I've just gained 1 plus 2 points, 3 points. The cannonball hits its target on the ground n seconds after it was fired. So let's go ahead and find out what that is, right? So I'm going to go to my calculator, go to my y equals, across from y2, I'm going to put the number 0 in, and I want to find out where these two graphs intersect. I already know 0, 0 is 1. This is where, well, the cannon was fired here from the height of a tower of 8. So I want to find out where this point of intersection is. So I hit second, I go to trace, I go to option number 5, and I already know that value, so I don't need to go ahead and do that. But I'm going to move my cursor over to the right as much as possible. This is being annoying, but you get the point. Enter, 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 and it gives me that. No, that's not the one that I want. Let's try that again. Option number 5. Right, so fast forward, enter, 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 and it's going to intersect, keeps pushing me back. So real quick, the reason why it's doing that is because I need to make my X max a little bit longer or further down. So instead of 10, let's go ahead and do 15, hit graph, and I'm going to repeat the process and show you. All right, so this is where I want the point of intersection. And over here, it tells me that my point of intersection is about 10.4. So the value of n is about 10.4, and this is in seconds. Okay, good. Find the value, find h prime of t. So I'm going to derive this. So 2 times negative 2 is equal to negative 4t. 2 minus 1 is 1, plus 20 is my derivative. Boom, calculate the maximum height reached by the cannonball and write down the corresponding time. So I'm going to go here. I'm looking for the maximum, so second trace. Option number 4 is my max. And then I'm going to go to the left of the mountain peak. Again, you should be doing this with me. Please do not just watch me do it. That is not going to help you in your learning. All right, so we're going to go a little bit to the left of where the mountain is. I'm going to go ahead and hit enter. I'm going to go a little bit to the right of where the mountain is. So somewhere around there, sure. And I'm going to go to where I think the mountaintop is, somewhere around there. And it's going to give me 5,58. Okay, so I'm looking for the height. So the maximum height is reached at 58 meters. And it says write down the corresponding time. So this is after 5 seconds. 5 seconds. Okay, so this is our full points for this question. Done. Oh, let's do F. Let's get these 3 points right here. So it says determine the total time the cannonball was above the height of the tower. So this is where our function, which is negative 2t squared plus 20t plus 8, is equal to the height of the tower was 8. So I want to see where these two are the same. So I'm going to go to y equals. Instead of 0 here, I'm going to change this to 8, and I want to see where they intersect. So go like that again. So again, you're looking for intersection at this point. So sure, somewhere around here, and I can see that my intersection is at 10 seconds. So this is the total time. T is 10 seconds. Perfect. So those are our extra 3 points. All right, so next question. I have a function here. State whether the function is increasing or decreasing. So at -1, you could tell we're going down a hill. So this is decreasing. At 0, it's going up. So it is increasing. And at 1, here's 1, it's a little bit past m, and that is decreasing. It's starting its descent. Write down the value of d. So d is our, if you look over here, it's our intercept, our y-intercept. So our intercept is right here at -1, so d is equal to -1. All right, so now they give us a function. We already know d is -1, and we're looking to find out what the value of c is. So they're telling us this point lies on the graph, so wherever our y is, here's our x, here's our y, so wherever our y is, we're plugging in the number -1, and wherever our x is, we're also plugging in -1. So I have -1 is equal to -1 to the third plus -1 squared over 2. Look at the important use of parentheses, and this is -1. So -1 to the third power is -1 times 1, -1 is 1, plus -1 squared is 1, so this is 1/2. This next one, c times -1 is -c, minus 1 is equal to -1. 1 minus 1 is 0, so they cancel out. So I'm left with subtracting 1/2 on both sides. So to do that, I get -3/2 is equal to -c. And if I divide both sides by -1, I get c is equal to 3/2. So there is my value of c. Using your graphic display, so our calculator, find the coordinates of the local maximum. All right, so I went ahead and plugged in my function. So -x cubed plus x squared over 2. I just plugged all of that in. I just found out my c was 3/2, so I plug in 3/2 there, and my d is -1. So if I go ahead and hit graph, if your graph's not showing up like this, you could do zoom option number 6, which is standard. And I'm looking to find out what this local max is. So I'm going to hit second trace. At this point, y'all should be really good at this. Yeah, I said y'all. Okay, so I'm going to go a little bit to the left, a little bit to the right. When my calculator does that, hit enter, and I'm going to go to where I think my maximum is, and I'm going to hit enter, and it'll give me my coordinates. So it's 0.893, 0.026. So 0.893, comma 0.026 is my coordinates of my local max. And now I'm finding the derivative of f of x, which is this right here. So 3 times -1 is -3. X, 3 minus 1 is 2, so that's -3x squared, plus 2 times 1 is 2x over 2, plus c is 3/2. We don't need to put the x, and this goes away. So there's my derivative. I can make this a little bit better by writing it as -3x squared. This is f prime of x. Plus, this cancels out, x plus 3/2. So there is my derivative, okay? The next thing I'm going to do is I'm going to find f prime of 0. So I'm plugging in 0 here for my x's. And when I do that, I get f prime of 0 is equal to 3/2. Okay, so again, x is 0 here, so this cancels out, and I have 3/2. Find the equation of the tangent. Okay, so this is part 2. So to do that, I have my formula y minus y1 is equal to m parentheses x minus x1. So this is the equation of a line. I just found out, so I have this point right here, which is x, this is my y. So I'm going to plug some numbers in. So I have y minus, my y1 is -1, is equal to, I just found out up here that my slope at 0 is 3/2. So 3/2 x minus, and my x1 is 0, 0. So negative negative is a positive, so y plus 1 is equal to 3/2 times x is 3/2 x, and 3/2 times 0, I don't need to write that down, minus 1 on both sides, and I'm left with y is equal to 3/2 x minus 1 is the equation of my line. So this is the answer to part 2. Part 3, write down the gradient of the normal to the graph at x equals 0. That's basically saying take this number right here and write down the negative reciprocal of it. So reciprocal of 3 over 2 is 2/3, and it's negative reciprocal, so this is negative 2/3. Okay. Part G, using your graphic display calculator, find the x coordinates where f of x equals negative x. So I'm going to go here. I'm going to go to my calculator, and over here I'm plugging in f of x, which is y, is equal to negative x. So here, so I'm looking for those 3 points of intersection. I think we've done intersection enough that you can, at this point, do this by yourself. So here are 3 coordinates. It's where x is equal to negative 1.54, x is equal to 0.393, and where x is equal to 1.65. And again, I'm looking for the 3 points of intersection, 1, 2, 3, by hitting second calc, option number 5, and then doing your little enter, enter, enter. Okay, so that's how I get all 3 of those coordinates. I just repeat that. All right. Question number 4. Part of the graph is shown. Da, da, da. Write down the y-intercept. So my y-intercept is right here. I'm looking to find out what that is. And here it tells me that it's going to equal -2, right? There's my y-intercept right there. I could also put in x is 0 for each of these and do it that way. Either way, I still get the same answer. Like, there we go. Thank you for working with me. So if I plug in 0 in for the x's into the original, I get my y-intercept at -2. Perfect. So that is my coordinate is going to be 0, comma, -2. And then I'm going to take my function, which is this right here, and I'm going to differentiate it. Okay, so I'm going to put my answer for part B up here. So 3 times 1 is 3. Let me do this a little bit better. This is the graph of f prime, the equation of f prime of x. So 3 times 1 is 3, x, 3 minus 1 is 2, plus 2 times p is 2p, and then x, 2 minus 1 is 1, so I don't need to write that down, minus 9. Okay, this goes away when I differentiate, and so there is my derivative. So let me just go down here and just write that a little bit neater. So this is equal to 3x squared plus 2px minus 9 is my derivative. So they gave us a very important fact here. They told us that the tangent line L to the graph at y or f of x at x equals 1 is parallel to the x-axis. Okay, so what that means is the derivative at 1 is equal to 0, right? It's parallel to the x-axis. So that means that the slope is 0. So we're going to take our derivative, which is this right here, and wherever we see an x, we're going to plug in the number 1, and we're going to set that equal to 0 to find out the value of p. So we have 3, and again, instead of x, we're plugging in the number 1, squared plus 2p, instead of x, we're plugging 1 in, minus 9, and we're setting this equal to 0. So 1 squared is 1, times 3 is 3, plus 2 times 1 is 2, so that's 2p, minus 9 is equal to 0. I'm going to take it right here. 3 minus 9 is equal to -6 plus 2p is equal to 0. Add 6 to both sides. Cancels out. I'm left with 2p is equal to 6, and I get, divide both sides by 2, I get p equals 3. Okay, so I just found out the value of p. Using that, we're going to use that to find out the equation of line L. So to do that, we're going to take, we have the original function now. We just found out what p is, right? So if I go over here to the original function, I now know what my p is right here. So I can go ahead and use that to help us. All right, so I'm going to plug in my original function with the value of p here now, and I'm going to go and look for where what number is across from 1, because this is x equals 1, so across from 1 is -7. So I have my point 1 comma -7, and I'm going to use that to help me figure out using my point slope formula. So let me just go ahead and write it in red. So y minus y1 is equal to m parentheses x minus x1. So I have my x and I have my y. So I have y minus my y1, which is -7, is equal to m. We just found out that the tangent line uh, is the slope is equal to 0. So I have 0 times x minus x1, which is 1. And then when I do this, 0 times anything is just 0. So I have y, negative negative is a positive, so I have y plus 7 equals 0. Subtract 7 on both sides, and I get y is equal to -7 is my equation of line L. For the next one, I'm looking for the coordinates of another point where the tangent is going to be parallel to the x-axis. So I went ahead and graphed my equation again, but I noticed that my window is a little bit smaller, right? I need to see what's up here. So it looks like I have to hit window, and I want to change my y in this case to see what's up on top. Let me go crazy with it and just do 50. And if I go like that. All right, perfect. So now I can see that right here is also where the line is parallel to the x-axis. That's where the tangent is going to be. So I want to find out this maximum point right here. And to do that again, second calc, option number 4 is maximum. So I'm going to look a little bit to the left. So take your cursor, move it to the left of the mountain peak. Again, if I'm doing this, you should definitely be doing this as well. So anywhere to the left, hit enter. We're going to go to the right of the mountain peak and hit enter as well. And then you're going to go to where you think it is, somewhere around there, hit enter, and you will see -3 comma 25 is the other point. -3 comma 25 is another coordinate of the point. All right, letter E. Write down the interval where the function f of x is negative. Okay, so again, right here, this is where this function is negative. So it looks like we just found out that this number is -3. This number right here, this minimum right here is at 1. So you can find this max, find this min, and you could say that the interval is from -3 to 1, right? And that is where, or you could write it this way, from -3x to +1. Okay, so either answer is completely acceptable for the interval. Part F, determine all values of m for which f of x is equal to m. And they're even telling us it has 3 solutions, so write down your answer using interval notation. All right, so getting back to our curve, so we just found out that this point is 3 comma 25. That's a max. Sorry, my bad. -3 comma 25. This min is 1 comma -7. So we're looking to see where the graph has 3 solutions. So if I put my line over here, I can tell it doesn't have 3 solutions. If I put my line anywhere over here, it does not have 3 solutions. But if I take this line and I put it anywhere between this range right here, like if I draw it here or here or here, anywhere between 25 and -7 with the y's, I'm going to have 3 solutions, right? It's going to be crossing at 1, 2, and 3. I think you kind of get the point, right? If I draw another line here, it crosses at 1, 2, and 3. So I see that my interval is between -7 and +25. So there is the answer to this last question right here. Determine all possible values. It's going to be from -7 to +25. So somewhere between there, or you could have written it as -7. Y is going to be between -7 and +25. So that is going to be the interval. Okay, good. Last question. That was definitely wishful thinking, but second to last question, penultimate question. So I'm going to find the derivative of this function. 3 times 8 is 24. X, 3 minus 1 is 2. Minus 2 times 24 is 48. X, 2 minus 1 is 1. Plus, this is going to be 28. So there is my derivative. For the next one, marginal cost, da, 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 is the cost of producing one additional unit. So find the marginal cost when 100 brackets are produced. So to do that, all we're going to do is dot, 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 in this context. So if you take a look, X is in hundreds of brackets. So here, we are looking to see where the X is equal to 1, because this is 100, okay? So we're going to take 1 and we're plugging it into the function that we have right here. So we're going to do 24 times 1 squared minus 48 times 1 plus 28. And then we have to explain its meaning. But this is going to equal, when you do this, this is going to equal straight up 4. Okay, so what does that mean? This is 4 hundreds of Japanese yen. So this is 400 Japanese yen. Perfect. So the marginal cost when 100 rackets are produced is 400 Japanese yen. For every additional racket that's produced, the cost increases by 400 Japanese yen. Okay, that is in context or interpreting the meaning in this question. All right, part C. Just go ahead, pause, take a drink of water. All right, so R of X is equal to 26X. So given profit is equal to revenue, which is 26X, minus cost, which up at the original part of the problem, it told us that the cost was 8x to the third power minus 24x squared plus 28x. So we're going to go ahead and simplify this a little bit. So there's an imaginary -1 here. Distribute that. So you're going to get 26x. -1 times 8x cubed is -8x cubed. -1 times -24x squared is +24x squared. -1 times +28 is -28x. We're going to combine some like terms. So these two are alike. So final answer for profit is going to equal -8x to the third power plus 24x squared. And then 26 minus 28 is -2x. Okay. All right, so for part D, we're going to go ahead and take this right here. We're going to differentiate p of x. So we're going to go ahead and differentiate this function that we just found out. So this is equal to 3 times -8 is -24 x squared plus 2 times 24 is 48x. And this is -2. All right, so there is the derivative. For the next one, for part A, determine the intervals where p of x is decreasing and increasing. So this is straight calculator. All right, so I plugged in my function p, which is -8x to the third plus 24x squared minus 2x, and I'm trying to find out this maximum point right here, so I can help differentiate where it's increasing and decreasing. So from this point down, it's decreasing. So we can go ahead and now answer this question. So p of x is going to be increasing from 0 up until from 0 to 1.96 to that point of maximum. and it's going to be decreasing. Remember, we're not using any negative numbers. It's going to be decreasing from 1.96 until infinity, right? That is where it's increasing and decreasing at. For the next part, for part F, the derivative p prime of x gives marginal profit. Awesome. They're even giving us some clues. So we're going to go ahead and it's telling us the prediction will reach its optimal level when the marginal profit is 0. So we're going to use our information that we just got. So P of our maximum point is 1.96 is equal to, so we're going to go ahead and plug in 1.96 right in here for x. So negative 8 times 1.96 to the third plus 24 times 1.96 to the second power minus 2 times 1.96. So you just take that, plug that into the calculator, and this will give you about 28. So what does this mean in context? So find the optimal production level. So optimal production level is going to be 1.96, but this is hundreds. So that is 1.96 times 100, which is 196. So optimal production level is at 196 rackets, and they also want us to talk about the expected profit. Expected profit at that level is going to be, so this is 2800s, so 2800 Japanese yen. Okay, so that is our answer for part F. All right, now last question. All right, so first thing I did is I took this function that they gave us and I rewrote it in calculus friendly terms right here. So it's a over 2, a is a constant. So this is x to the negative second, so I rewrote it like that. So our derivative is going to be negative 1/3, right? So this is 1. 1 minus 1 is 0, so that goes away. So negative 1/3 minus, and negative 2 times a is going to be negative 2a. Divided by 2. And this is going to be x to the negative third power. So I can write this a little bit better, right? This cancels out. I put a negative, but then so this is supposed to be a plus. Okay, so then I'm going to go ahead and make this a little bit better. So this is the same thing as negative 1 over 3. And this is positive, negative is a negative. So the 2's canceled out. So I'm left with a. And x to the negative third gets kicked to the bottom. So this is x to the third. So this is what f prime of x is equal to. All right. So next thing that they tell us is there's a local max at x equals 3, which means that if I take the derivative of 3 and I plug it in, I get 0 as an answer. So they just want us to show that a is equal to negative 9. They're even telling us that. So I'm going to do negative 1 over 3 minus, so I know what I don't know what a is. I'm going to pretend that I don't know what a is, over, and my x is 3, right? Because I'm plugging 3 in here. So this is 3 to the third power, and I'm going to set that equal to 0. So add 1/3 to both sides, plus 1/3 plus 1/3. So this cancels out. So I'm left with negative a over 3 to the third is 27 is equal to, this is 1/3. At this point right now, I could go ahead and cross multiply here. So negative a times 3 is equal to negative 3a is equal to 1 times 27 is equal to 27. Divide both sides by negative 3. This cancels out, and I'm left with a is equal to -9, right? Which is what they told us, so they just want us to show it. We now have the completed function, right? So find the y-coordinate of the local maximum. All right, so we're almost in for the long haul. We're almost done. So all I did is I took my original, which is right over here, right? And I plugged in -1/3 x, boom. So this is plus, my a is -9, so I just put -9 over 2x squared, or you could put a plus -9 over 2x squared, same thing. And now I'm going to go to my table. They're even telling me that my local max is at x equals 3. So across from 3, I see -1.5. So there is my local maximum, -1.5. I just want the y-coordinate. Boom. Sketch the graph. I'm going to go ahead and change my window to the dimensions that they tell us. So from -6 to 8. So -6 to 8. And then for my y's, they want it to be from -6 to 2. So -6 to 2. So you're going to hit graph, and you're going to sketch this under this part right here. So that is how the graph is going to look. So sketch it. Right? I'm not going to go ahead and do that because this is a timed assignment for me. State the values of x for which f of x is increasing. So we can look and see that from, so where is it increasing, right? So from 0 to about this maximum right here at 3 is where it's increasing. So we could just go ahead and write that. It's from 0 to 3 is where the graph is increasing. All right. Part F, find the x-intercept of the graph of f of x. So I'm looking for my function. I'm looking to find out what my intercept is right here. So to do that, I go to y, change this to 0. My bad. You can tell I'm getting tired. Hit second, trace, option number 5, which is intersection. And I want to find out this intersection right here. So let me go to my calculator, go somewhere around that point. So I know it's going to be around -2 something, a little bit past that. So somewhere around there, hit enter, 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 and it gives me -2.38, comma 0. So x-intercept -2.38, comma 0, and then calculate of f prime of 1. So I'm going to take my derivative, which I have. So I have f prime of x, just to refresh our memory, is equal to -1/3 minus 9 over x to the 3rd power. So all I'm going to do is wherever I see my x, I'm plugging in 1 here. So f prime of 1 is going to equal 26 over 3. All right, so that is that answer. And last but not least, letter H. So find the equation of the normal, which is basically finding the negative reciprocal, right? So I'm going to take this function that I just got, so 26 over 3. The negative reciprocal of that is going to be -3 over 26. So my new slope is -3 over 26. And we want the coordinates of f of x at x equals 1. So I went to my calculator across from, I'm looking at x equals 1, right? So across from 1, I see -29 over 6. So 1 comma -29 over 6. First number is my x, second number is my y. And last but not least, I'm going to go ahead and put these two thingies together. So we have y minus y1 is equal to m parentheses x minus x1. So y minus my y1 is right here, -29 over 6 is equal to m is equal to -3 over 26, parentheses x minus, and my x1 is 1, right? So I could take this, write this a little bit better. So I have y negative negative is a positive. 29 over 6 is equal to, if I do distributive property here, I get negative 3 over 26x. Negative negative is a positive, so plus 3 over 26. Okay, so I have that. I can subtract 29 over 6 from both sides, and I get as my final answer y is equal to negative 3 over 26x. And when I subtract 3 over 26 minus 29 over 6, I get 184. It's negative 184 over 39. And your calculator will give you that answer. You do not need to do that in your head. All right, long video, but we're done.